Okay, my dear friends, so let's continue our revision on paper 4, 0625, paper 4, variant 3, and May June 2023. Most of this paper we have solved already, and our discussion now, waves is solved, even thermal is solved, and electricity we did not solve. So we will start with the electricity questions and then space physics electricity questions, and see one question is solved and one is not solved. So let's solve first this electricity question. Also this is a bit tricky. Now come here, the diagram, the question is in front of you. Let me write once more. This paper is from summer, mean May June 2023. This is paper 4, variant 3, which is under our discussion, and we are solving question number 6 right now. An electric heater uses a resistance wire of resistance 26 ohms. The power dissipated in the resistance wire is 2500 watt. Calculate the current in the resistance wire. Now we are given with resistance of the wire, and we are given with the power dissipated. Dissipated mean wasted. Dissipated also mean the power which is spreading apart. So calculate the current in the resistance wire. My dear friends, there are three equations which we can use to calculate power. One is current times voltage. This we cannot use in this scenario because we need to find current and we are not given with voltage. Second one is power is equal to V square over R. V should be capital. So this also cannot be used as voltage is not there. And the third equation is I square R, and this equation will work for us for this scenario right now. So power is equal to I square R. Then we can also solve, we can make current as the subject of equation. So I square will be equal to P over R, and then taking the square root on both sides. Square root on this side, square root on this side, so this root will cancel the square. So current is equal to power, which is 2500, over resistance, which is 26, and then the root. So current is equal to, my dear friends, here 2500 divided by 26 equal to 96.15, but we need to take the square root of this. So answer comes to be 9.805. Current is 9.805. So we will write just 9.8, or if you want to write more, you can write 9.81 also. That will be okay, but even minimum two significant figures are allowed, and we are using two significant figures right now. The next part is, yes, bit tricky here. The resistance wire of the heater has a length of 1.2 meters and a cross-sectional area of 7.9 times 10 raised to power minus 7 meters square. This is the same wire which is having a resistance of 26 ohms, which is being used already into the electrical heater. Now a new heater is designed using the wire of the same material. Means if the first wire was nichrome, so this wire for the second heater, okay, if the wire in the first heater was made up of nichrome, now the wire for the second heater is also made up of nichrome, but with different dimensions. When I'm saying different dimensions, it means I'm talking about different length, width and height at cross-sectional area. Before length was 1.2 meter, now length is 1.8 meter. Length is increased. So it means resistance of the wire will be increased from the length point of view. Cross-sectional area, that is decreased now, because before it was 7.9 times 10 raised to power minus 7, now it is 5.8. Area is decreased. It means again a resistance will be increased. Now calculate the resistance of this wire. What we are going to use, or going to do, we are going to do two factors we are going to use. That resistance is directly proportional to length. Resistance is what? It is directly proportional to length. Now if the length is increased, it means resistance is increased. But let's check how much length is increased. 1 over 8 meters divided by 1.2 meters. Let's take the ratio of length, that is equal to 1.8 divided by 1.2, answer is 1.5. So it means the length is increased by 1.5 times. Resistance is directly proportional to length, so resistance will also be increased. So what will be the resistance now? Before it was 26, but as length is increased by 1.5 times, so it will be equal to 1.5 times 26, and it is 39 ohms. So the changes in the length are causing the resistance from 26 to be 39. As the length is increased, so resistance is also increased. Let's see what happens to the area of cross section now. Area of cross section, resistance is inversely proportional to area of cross section. If the area of cross section will be increased, the resistance of the wire will be decreased, and if the area of cross section is decreased, then the resistance will also be what? Increased. Now let's check how much area is, what is the factor of the area. So 7.9 times 10 raised to power minus 7 meter square over 5.8 times 10 raised to power minus 7 meter square. Now my dear friends, 10 raised to power minus 7, 10 raised to power minus 7 cancelled, meter square cancelled by meter square. So how much time the area is decreased? I will do it 7.9 divided by 5.8. So it is 1.36 times. So I am writing here that area of cross section is decreased by, arrow downward, area of cross section is decreased by 1.36 times. So resistance will be again increased. It means now final resistance of this second heater wire with different dimensions will be equal to 39 times 1.36. Why times 1.36 again? The reason is, in the first case, resistance is directly proportional to length. So length was increased by 1.5 times, but area is and resistance is inversely proportional to area. So area is decreased, so resistance will be again increased. So we need to multiply it again. So let's see what is the answer. 1.36 is already there, times 39, answer will be equal to 53.12. So simply we can write here 53 ohms. So this is a bit out of the way question. After years it is repeated. That's why I have come to this question and we have solved it right now. So this is the common phenomena which must be in your mind, and but basics of the factors affecting resistance must be in our mind. There are basically three factors. Even fourth is also there, but not exactly right now in the syllabus the way it was before. But resistance is directly proportional to length, one factor. Here length is increased, so resistance is also increased. Resistance is inversely proportional to the area of cross section. Area of cross section in this case decreased, so again the resistance will be increased. That is the reason in both these steps we multiplied by the factor the given resistance. Third factor is material. Material was here same, and the fourth factor, which is not now directly with us, that is the resistance is also directly proportional to temperature, but this we are talking about the resistance of metals. Okay, now another question which is introduced from 2023, the cost of electricity stuff. Now see here my dear friends, that a 2500 watt heater which was mentioned above is used in a country where the electricity cost is $0.30 per kilowatt hour. Per kilowatt hour. Calculate the cost of using the heater continuously for 2 days. If it is 2 days, how many hours? Time will be equal to 2 times 24 hours. So it means time is basically 48 hours. Why we need to use time in hours? See, the price is per kilowatt hour. So time should be in hour and power should be in watts. Power should be in what? Watts. So power is in kilowatt. So we can make it 2500 divided by 1000. So it will be no more in watts. It will be equal to power in kilowatts, and that is equal to 2.5 kilowatt. Now, cost of electricity. energy. First of all, we need to know energy in kilowatt hours. So what is the formula for that? Power in kilowatt times time in hours. So you can check the key points shared with you people from chapter 18. The very last topic is this one. So power in kilowatt, how much is that? 2.5 times time is how much? 48. So 48 times 2.5, it is equal to 120 kilowatt hour is the total energy consumed in 2 days by making use of that electrical heater. So what is the cost? Now this is the energy in kilowatt hour. And why do we need energy in kilowatt hour? Because the price is given $0.30 per kilowatt hour. So 120 kilowatts are total and each kilowatt is $0.30. So as we will simplify it, 0.3 answer is 36. So my dear friends, $36 will be the price of the use of electrical heater for 2 days in that country or in country home. Please, if you have any question here, feel free. You people can ask me right now. There is not a problem, not at all a problem. If there is anything, please feel free. You can raise your hand and I can start explaining you. Next question we have already solved. It was so simple. We discussed it already. Now let's move to nuclear physics question, nuclear and atomic physics question. During a beta decay, one of the neutrons in the nucleus changes. State what happens to this neutron. State what happens to this neutron. So let's start. What happens to this neutron? This neutron is broken into one proton and one electron. So what happens to this neutron? Before I write the answer, I'm going to write the answer. Neutron 0 and 1, it changes to one proton and one electron, which is a beta particle. So during beta decay, one of the neutron in the nucleus changes. State what happens to this neutron. So we will answer that this neutron is converted to one proton, or it is changed to one proton and one electron. One proton and what? One electron. So I'm going to write the same thing here, my dear friends. Okay dear, so what happens to this neutron? It changes to one proton and one electron. Even if you want to write, you can write beta particle again, but during beta decay. So okay, one electron, that is suitable, no problem at all. Now explain how charge is conserved during this change. So better you should write here this equation now as I have written up. So 0 and 1, it changes to one proton and one electron. Now see, charge on left hand side are no need, just write charge is equal to 0 and then plus 1 minus 1 is also equal to 0. So charge is conserved. conserved mean it stays the same. They said only charge, so don't consider about the nuclear number. So charge in the beginning, that is 0. Charge on left hand side, let me write on left hand side, charge is equal to 0, and on right hand side of the equation, charge which is plus 1 minus 1 also equal to what? 0. So charge is conserved. Write it this way. Next, complete the nuclide equation for alpha decay of radon 212 to form an isotope of polonium. Symbol of polonium is, see this, and it converts to what? It converts to PO and 1 alpha particle. So to alpha is 2 alpha 4. So polonium, it will be 84, and here 208. Charge is conserved and mass is also what? Conserved. Charge is conserved as well as mass is also conserved. Okay. Now next is, my dear friends, nuclear this is a unique question, by the way, a very good question. Okay, let's start it. Now see, figure 9.1 shows the sun as the central dot and the planets Saturn, Jupiter and Earth labeled SO, JO and EO. The planets orbit the sun anti-clockwise. Check, the direction is given. They are rotating anti-clockwise, and you know, anti-clockwise, for memorization you can say left hand side turn. Turn on left hand side, anti-clockwise. So sun is there in the center. Figure is not to the scale. Assume that the Saturn takes 30 years. Saturn takes 30 years to orbit the sun, and Jupiter takes 12 years to orbit the sun, to complete one complete circle orbit. On figure 9.1, mark the positions of the Saturn and Jupiter after 5 years. Jupiter years, okay, wait. On figure 9.1, mark the positions of Saturn and Jupiter 5 years after the original positions shown. Label these positions S1 and J1 and show your working. Show your working. Here, my dear friends, we did not study anything to know their location this way, but we know one thing. When they will complete one orbit, it means they will complete one whole cycle and 360 degrees will be there. Now, see, first of all, I will do it for Jupiter. Jupiter takes 12 years to orbit the sun. So, for Jupiter, in 12 years, it will make a turn of 360 degrees. 360 degrees. And what the time they have given? 5 years. So, if I am writing here 5 years at the bottom, so how much angles or how many degrees Jupiter will make a turn in this time? Just the ratio of the years to the ratio of the turns, sorry, angles or orbitation. Now let's cross, and year is cancelled with year, so let's cross multiply angles turned by the Jupiter in 5 years. That will be equal to 360 times 5 over 12. If anybody is having a problem, please feel free, you can ask me. Now 12 3s are 36. Between 30. So it means Jupiter will turn 150 degrees. Please make use of your calculators and let me know if this is correct or not correct. And we have to show the working. That's why I'm calculating these numbers. So what I did, see, Jupiter is taking 12 years to complete to orbit the sun. So it means in 12 years one cycle is complete. So it means 360 degrees are 360 degrees it has turned. Now what will be the position of Jupiter after 5 years? So the ratio of the years is equal to the ratio of the degrees. So 12 years over 5 years is equal to 360 degrees over theta j. What will be its position? And when we have solved it, answer came to be 150 years. Thank you, Ahmad Abdu, your son. Stay blessed. Now we have to do the same phenomena for Saturn. What are these balances? Okay. Now see, it takes 30 years to orbit the sun. So in 30 years it will make 360 degrees turn. And how much time now given? 5 years. Yes, yeah. So for both of them 5 years. And how much Saturn will go? We will check. So here is cancelled with here. So theta or angles for Saturn, it will be 360 degrees times 5 over 30. So 0 is going with 0. So 12 3s are 12 5s are 60. So I think it should be how much? 60 degrees. Yes, my dear friends. Yes, okay. Thank you. Abdul, correct. Okay, now if anybody is having any problem regarding this, please you can ask me. Very simple, that in 30 years, this Saturn is making one turn around the sun. It means 360 degrees in radian displacement or angular displacement, like this you can say. So 360 degrees. How much in 5 years? So ratio of the years will be equal to the ratio of the degrees, angles. So when we calculated 60 degree, and same phenomena for Jupiter 150 degree. Now what to do? Come back to the diagram. 60 degree for Jupiter. Sorry, 60 degrees for Saturn. See, if I'm putting the protractor here 0. Here it will be almost, here it will be 180. It means here in the center almost it will be 90. And here it will be what? 270, and this is again 0 and 360 degrees. You can use your protractor. How to put the protractor? I have just marked the rough values. How will you place the protractor? Again, as usual, as I'm seeing you people, now place the protractor roughly like this. Okay, read from 0, and where it will be 60, almost here it will be 60. So you are supposed to write S1 there, S1. Wherever it is 60, so just put a line or something and write S1. This is for Saturn. What about Jupiter? For Jupiter, my dear friends, it is 150 degrees. So see, same phenomena for Jupiter also, same process. My goodness. Same process, see, but here, see 0, 90, this will be 180, 270, and so 90 and 180. Here 0, here 270. So my dear friends, 150. 90 plus 60, it will be 150. So protractor again the same position, almost you can say here, that will be J1. So this is the position for Jupiter after 5 years. You will use your protractor to do all this, but I have given you just the rough sketch: 90, 180, 270 and 360 degrees and 0 degrees, and inshallah it is correct, but concept should be very clear. Please, if any one of you is having a question, feel free, you can ask me. Even after the lesson, you can send me a message and you can ask me, and I will put these recordings already for you people online. Okay. Now, let's move to the next. It is the same, only 1 mark. No, how many marks it was? It was for 3 marks. Okay, now only 1 mark. On figure 9.1, mark the positions of Saturn and Jupiter after 20 years. Sorry, 20 years after the original position shown in figure 9. So now for 20 years, let's do it quickly. Please pick up your calculators, my dear friends. For Jupiter, now it will be how much? It was 12 years, I think. Forgot. Yeah. So now we can make 12 over 20 equal to 360 over theta j. Cross multiply. So theta j is equal to 360 times 20 over 12. So 12 threes are 30. Oh, it is too much. Roughly, I will say 600 degrees. Please confirm if I'm wrong, so you can use calculator correctly. Similarly, for Saturn, that is 30 over 20 is equal to again 360 over theta s. So theta s in this scenario 360 times 20 over 30, so 30 12 12 so this is 240 degrees. My dear friends, please quickly, 600 degrees. And what about the second one? Is it 240? Yes. Okay, thank you, my dear son. Stay blessed, my dear students, stay blessed. Thanks a lot. So now yes, okay, Maida Ahmad Abdul, correct, thank you. Now 600 and 240. Okay, I'm sure these angles are okay with you how to draw. So I'm rubbing this so that we can make. Now again, and let me choose another color, the dark color. Okay, now for Jupiter it is 600. So okay, one complete cycle, 360. So 600 minus 360. So I'm doing theta for j. So 0 0 10 240. It is 240. Okay, no problem. So now see 180 plus 60, 240. So somewhere here. So now how to denote it? J2. Yeah, J2 and S2. Okay. So Jupiter will be here, and that will be J2. And see, and for Saturn it is also 240. So it means they will be in line. So for Saturn also somewhere here. So this will be S2. Please, my dear friends. So same position. They are in line, one behind the other. So this was, of course, the question. That's why I have this. Now state what is observed from Earth's orbit after 20 years. That's what I told you already. After 20 years, see, before Jupiter was here, and after 5 years, and Saturn was here. They were not in line, but now you can see they are. If you will observe them from Earth orbit, so Jupiter and Saturn, they will be in line. They appear in line from Earth. Both planets appear in a line or align, whatever. I think better. Okay, in line. Okay. From Earth. First, I need to take the question. Is there any question? No. Ahmad Abdu, my dear son, good question. How to use 600? I told you no need to use. There is no 600 in the protractor. It is up to 360. So what I did, see, you did not, I think you missed that point. See, for Jupiter's angle is 600. So minus 360 degrees. See, Jupiter, please, I will draw the line, but then I will rub it. See, it will take one complete round trip, 360. Still 240 are left. See, why 240 are left? Because 600 minus 360, 240. So then it will come, and here it will complete. Sorry, I have chosen the orbit of Saturn. It was not for Saturn. Actually, this is for Jupiter. See, Jupiter will start from here. It will complete one complete cycle. Once completely it will orbit. It means 360 degrees are gone. Then plus 240 more. So that's why up to here this is 240. So Saturn, for this Jupiter, my dear son, we will go this way. Ahmad Abdu, your question is valid. Others are sleeping. I don't think so they bother to ask me. But see, 600 mean one complete round trip, and then 240 degree more. That it will do in 20 years. Okay. So actually some of my students asked me from evening shift and morning shift in school to explain this question. So that's why when I checked this year, I said I have done with you this paper but not completely. So that's why I have came to this point right now. I think from Earth I should not write, but you should write both orbits appear in a line. That's better. Or they are aligned. That will be okay. Now choose two words from the list to describe each planet. Jupiter, of course, it is the largest planet, so large and gaseous. And what about Earth? That is small and rocky. Yes, fine. Okay. Now, the average density of Jupiter is much less than that of the Earth. The gravitational field strength at the surface of the Jupiter is greater than that at the surface of the Earth. Explain how these differences in density and in gravitational field strength are consistent with your answers to CI. So we have to give these questions this part answer by making use of this thing. No problem. Density. So density of Jupiter is less. So we can say density of the Jupiter is less because it is a gaseous planet. So I'm just using the shortcut. Okay, let me write completely. Jupiter's density is small than Earth because it is a gaseous planet. Gravitational field strength of Jupiter is more than Earth. It has gravitational fields. Okay. Jupiter has greater gravitational field strength because it has large mass. Largest planet, it has a lot of mass. Like in the solar system, the gravitational field strength of the sun is maximum because it is consisting of 99% mass of the whole solar system. So then after the sun, the largest mass is with Jupiter, so that's why it has a strong gravitational field strength, and we have made use of these words which are given there. Now the average density of the Jupiter is this. Density is given and volume is this. Calculate the mass of the Jupiter. Be very careful. 3 marks are there due to some reason. So density is equal to mass per unit volume. Cross multiply mass will be equal to density times volume. So now density times volume, density is 1300 times volume is 1.4 times 10 raised to power 15 times 10 raised to power 9. Please simplify it first and let me know. Tell me the name. Tell me the answer. Write the answer in the chat box. Okay. So why 10 raised to power 9? I will be telling you, because when we are converting kilometers to meter, we multiply by 1000 or 10 raised to power 3. Kilometer square to meter square we multiply with 1000 square or 10 raised to power 6. And when kilometer cube to meter cube, we will multiply with 1000 cube or times 10 raised to power 9. So this was the reason I have multiplied it with 10 raised to power 9. So answer is 2 options I have received by the students. So 1.82 times 10 raised to power 27, Maida correct, Ahmad Abdu correct, mashallah, same answer from both of you. So thank you, stay blessed. 1.2 1.82 times 10 raised to power 27 kilogram. Okay, still it is 12 marks question. Oh, this year I think they like this uh, space physics. 12 marks plus 7. Oh my goodness, 19 marks are from space physics out of 80. So almost 20%, almost 20%. Oh my goodness. Anyhow, show that 1 light year is equal to this. So light year is a distance. It is the distance traveled by the light in space in 1 complete year. So we will be making use of the formula V is equal to distance over time. So light year is not a time, it is distance. And see, hint is meters. So V times T. So V, speed of light is 3.0 times 10 raised to power 8 meters per second. Time is 365 days. Each day has 24 hours and each hour has 60 minutes and each minute has 60 seconds. When you will simplify, you will get 9.46 times 10 raised to power 15. So you can round it off to 9.5 times 10 raised to power 15 meters. Very simple. Very simple. Please, if there is any doubt or question, feel free. You can ask me. Now, state 1 measurement that is taken when measuring the speed v at which a galaxy is moving away from Earth, that is change in wavelength. Redshift, change in wavelength. Actually, wavelength is increasing, so you can say even increase in wavelength. That will also work. Write down the equation relating v and distance for a galaxy. So v is equal to h naught d. H is the Hubble's constant. State how the distance d of a far galaxy can be determined other than by using the equation in the brightness of the supernova or brightness of the supernova is okay. What is assumed that the supernova or the galaxy giving out more light, it means it is nearer as compared to which is less bright. So brightness of a supernova. In this way, this paper is completed. Alhamdulillah. My dear friends, stay blessed.